미디어 프로젝트 14주 1차 강의를 시작하겠습니다. 이번 시간에는 기하급수적 기술 발전과 그 적용에 대해서 알아보도록 하겠습니다. 먼저 인공지능에 대한 전문가의 강의를 보겠습니다.
Manufacturing is fundamentally about manipulating atoms and molecules, and intelligence drives manufacturing.
과거의 역사를 보면 지능은 매니팩처링을 발전시켜 왔습니다.
Whether you're chipping flint or bone or soldering or welding or 3D printing, it's all about improving our knowledge of how to manipulate atoms and molecules.
우리가 원자와 분자를 어떻게 manipulate, 조작하는가에 대한 지식을 개선하는 것입니다.
Here are 100 startups in AI in virtually every field of human endeavor: robotics, cybersecurity, automotive, fintech, commerce, Internet of Things, business intelligence, bots for interacting with people. And yet, most of these companies didn't exist 3 years ago.
인공지능을 사용해서 인더스트리를 변화시키는 100개의 스타트업인데 대부분은 3년 전에 존재하지 않았습니다.
This field is moving very fast. People often ask for definitions of AI. Here are a few of them: pattern recognition techniques to solve practical business and technical application problems, software agents that, if given some resources and a well-defined set of tasks, can solve those tasks in the minimum amount of time that they have available, a vision of superhuman intelligence that hasn't happened yet, even though movies and science fiction stories tend to blur that line, and computer science that's accelerating all of the other exponential technologies that you'll be hearing about over the next few days: synthetic biology, robotics, nanotech, and AI.
인공지능은 패런 레코그니션 기술과 소프트웨어 에이전트와 슈퍼휴먼 지능을 가진 비전과 다른 분야를 엑셀러레이팅하는 컴퓨터 사이언스 기술을 포함합니다.
Hardware and software tend to get most of the attention in AI, but what you'll see when you look behind the scenes of most AI startups and even research labs is an emerging symbiosis between human intelligence and machine intelligence.
우리는 현재 휴먼과 머신 간의 심바이오시스, 공생을 보고 있습니다.
At Carnegie Mellon, Libratis plays no-limit Texas Hold'em poker, and this system played 120,000 hands against 4 world champion poker players, and it ended up with $1.77 million worth of chips. It was a very non-random result, and why should you care? Because this system can handle bluffing and misinformation and create strategy to win.
카네기 멜론 대학에서 개발한 AI는 인간의 블러핑과 미스인포메이션을 다루고 이길 수 있는 전략을 수립합니다. 4명의 포커 플레이어 챔피언과 대결해서 200만 불에 가까운 수익을 거두었습니다. 이것이 가지는 의미는 인공지능이 자기에게 주어진 정보가 참인지 거짓인지 판단하도록 한다는 것입니다.
Ken Forbes at Northwestern has been working on a system called CogSketch for about 30 years. And just recently, 2017, in January, he announced that his system could solve the Raven progressive matrices test, a test of analogical and visual intelligence, better than the average American.
인공지능이 IQ 테스트에서 사람보다 더 높은 점수를 얻은 사례를 소개합니다.
What should go in that bottom corner cell out of these 8 alternatives? Anyone? Which alternative here? A through H? D, right, because it matches the symmetry in the row in the column where that empty cell is. Amazon Alexa, the agent running on the Echo speaker, connected speaker from Amazon, was the surprise winning gift in the Christmas season of 2016. Look at the growth of Amazon Alexa skills. Q1 2016, 135 skills. Q1 2017, 10,000 skills.
아마존 알렉사에 추가할 수 있는 third party 스킬은 빠르게 증가하고 있습니다.
These are things that you can speak to this artificial intelligent agent, and it can do things for you. And we're now building our AIs into our machines, in many cases, big machines, like cars.
자동차와 같은 큰 머신에서도 AI를 구현하기 시작했습니다.
Alexa is now being built into Ford's Focus and Ford's Fusion as an option.
포드 자동차에서는 알렉사가 빌트인으로 장착 가능합니다.
The historical trends in materials and manufacturing are absolutely clear. Increasing precision, eventually leading to atomic precision. We're not quite there yet. Decreasing cost, increasing flexibility, increasing velocity, and complexity is free.
물질과 제조에서의 추세는 분명합니다. Precision, 정확도를 향상시키고 코스트, 비용을 줄이고 Flexibility, 유연성을 증가하고 Speed, 속도를 증가하고 Complexity를 무료로 제공하는 것입니다.
Why is complexity free? Because a 3D printer or other similar robot for doing manufacturing doesn't care how complex the CAD or computer-aided design file is that you send it. It just operates with the feedstock that it has. Doesn't cost more.
컴플렉시티가 프리인 이유는 로봇과 3D 프린터는 컴플렉시티 증가로 인해서 추가 비용이 없기 때문입니다.
And even a master manufacturing company, a semiconductor manufacturing company like Intel, is realizing this. They recently acquired Nirvana, an AI company, and Naveen Rao, who was CEO of Nirvana, has now been made the head of an AI products group at Intel.
반도체 설계와 제조에서 뛰어난 능력을 보이고 있는 인텔도 AI를 이용한 제조에 큰 노력을 기울이고 있습니다.
Because they want to drive intelligence into every product and process that they have. AI contributes to manufacturing in a variety of ways, faster actions and decisions, innovative products, services, and materials, not just better, faster, cheaper, but different. Higher precision, lower cost, exponential scale, because you can now drive intelligence to the edges.
AI가 매니팩처링에 가져오는 이점은 다음과 같습니다. 빠른 액션과 디시전을 가능하게 합니다. 프로덕트와 서비스와 머티리얼을 혁신시킵니다. 효율을 개선합니다. 더 정확한 프리시전을 제공합니다. 코스트를 낮추고 익스포넨셜 스케일을 가능하게 합니다.
You know about IBM's Watson beating the two world champions in Jeopardy way back in ancient history, 2011. But now, IBM is driving Watson into virtually every area of business. They're still looking for new partners. And they have a Watson Explorer expressly designed for advice in manufacturing.
IBM은 매니팩처링을 비롯한 많은 분야에서 AI를 적용하기 위해서 노력하고 있습니다.
General Electric is using big data and AI to make smarter turbines. And by the way, they've been at this for 30 years. They had an AI group 30 years ago. I visited them, and their AI group at that time was working on predictive maintenance for locomotive engines.
GE는 데이터를 사용해서 더 나은 터빈을 만들기 위해서 30년간 연구해 왔습니다.
I want to give you a framework for thinking about the AI revolution, to really wrap your minds around it. And the framework involves 7 steps: capital, algorithms, hardware, data, talent, applications, and responsibility.
AI의 혁명을 드라이빙하는 것은 다음 7가지입니다. 먼저 캐피털, 자본이 있어야 되고 알고리즘, 하드웨어, 데이터가 있어야 됩니다. 이를 수행할 수 있는 탤런트 있는 사람들이 있어야 되고 어플리케이션은 현재 모든 방향으로 확장되어 나가고 있습니다. 또한 AI 사용에는 책임감이 따릅니다.
And responsibility is not just a throwaway item. You'll see that we take it seriously. Let's look at capital. 2012, 589 million invested in AI. 2016, 658 deals and over $5 billion of investment.
AI에 대한 파이낸싱이 급격히 증가하는 것을 볼 수 있습니다. 2016년에는 $5 billion, 5조 원 이상이 투자되었습니다.
Algorithms are also a key. Deep learning is the champion machine learning algorithm and its cousins, convolutional neural networks, recurrent neural networks, and others.
딥러닝을 비롯한 많은 새로운 알고리즘들이 발전해 나가고 있습니다.
Let me just show you a little bit about how this works. It's a hierarchical pattern recognition system. At the first stage of the hierarchy, you have a set of pixels, like in a photograph.
딥러닝 하이러키의 첫 번째 인풋, 사진입니다.
Here you have edge detection. So it's detecting vertical lines, horizontal lines, diagonal lines. The next stage, object parts.
첫 번째 스테이지는 수평, 수직, 대각선의 엣지 디텍션입니다. 두 번째 스테이지는 오브젝트의 파트를 디텍트합니다.
So the parts are ears, nose, mouth, eyes, etc. And the third stage, the objects themselves, faces.
눈, 코, 입 등의 부분을 인식하면 세 번째는 오브젝트 전체를 인식합니다.
And 3 layers of hierarchy is not enough to differentiate all of your beautiful faces, but we can build hierarchies with many levels. Microsoft announced a 152-layer hierarchy. You don't need anywhere near that much to do a great job on facial pattern recognition.
하이러키 숫자는 마이크로소프트가 152개를 사용한 것처럼 더 늘어날 수 있습니다.
And here is an article that just came out very recently from the DeepMind group at Alphabet. And this system was about something more than just recognizing objects, recognizing the spoon and the bowl and the hamburger and the Advil.
알파벳 그룹의 딥마인드에서는 오브젝트를 인식하는 것 이상의 결과를 발표했습니다.
This was about being able to pattern recognize how you would have to move a robot hand to grasp these objects.
AI는 패런 레코그니션을 통해서 물체를 어떻게 그래스프할지, 잡을지를 알아냅니다.
So a neutral wrist for picking up a Coke can, a pronated wrist for picking up an apple, a tripod kind of configuration of one's hands for picking up a toothpaste tube, and a pinch for picking up something like a pen or a knife.
물체를 짚는 모양은 손바닥과 리스트가 뉴트럴, 프로네이티드, 트라이포드, 핀치 네 가지 모드가 있습니다.
Now, sometimes people will tell you, don't try this at home, it's dangerous. I'm encouraging you all to try AI and machine learning at home. You can download the R toolkit for free right into your laptop. You don't need specialized hardware, and you can test this out. And if you don't have the chops, the programming chops to do it yourself, you can invite a high school student to help you. R has got 1,800 extensions to the standard toolkit. It's very, very powerful and free.
AI를 실험해 보기 위해서 R과 같은 패키지를 무료로 다운로드 받아서 해볼 수도 있습니다.
You can also use a platform like Sentient Technologies. They have 130 million of investment. Some of the people from the Apple Siri project, Adam Chaya and others, are involved in this. And they are using deep learning at massive scale and also evolutionary learning.
센티언트 경우는 진화적 지능을 딥러닝을 사용해서 매시브 스케일로 구현합니다.
They grow hedge fund agents and pit them against each other in a kind of simulated evolution of hedge fund agents in order to be very successful at making bets. And they also have recommendation engines that they simulate evolution and build ever better recommendation engines that way.
헤지펀드 시뮬레이션을 통해서 더 나은 베팅을 하는 것도 있고 레코멘데이션 엔진도 있습니다.
IBM is now labeling their Watson-fueled business cognitive businesses, and they're encouraging a wide variety of interaction there.
IBM은 클라우드 플랫폼을 통해서 다양한 분야에서 커그니티브 비즈니스를 추진하고 있습니다.
Check them out. And I believe in being honest about these technologies, and there are problems. I don't expect you to read this. I just want to show you a very recent research paper that I think went largely unheralded. This is a graph from some work that was done at DeepMind at Alphabet, where they addressed a really serious problem with machine learning. If you learn task A with deep learning, that's great. If you then use that same network to learn task B, you get what's called catastrophic forgetting.
딥러닝에는 catastrophic forgetting이라는 문제가 있습니다. 태스크 A를 배우고 난 뒤에 태스크 B를 배우고 나면 이러한 현상이 발생합니다. B를 어떻게 하는지를 배우기 위해서 A를 어떻게 하는지를 잊어버리는 것입니다. 따라서 딥마인드는 태스크 B를 배울 때 태스크 A의 네트워크 웨이트를 보존하는 법을 발견했습니다.
So it forgets how to do A when it learns how to do B. And they developed a system that would preserve the knowledge or the weights in the network of task A when it learned task B. So you can see with no penalty for losing that knowledge, you get fairly low performance on this graph, and then you get much higher performance if you preserve the knowledge of how to do the prior task. And it turns out this works so that you can do more than just two, you can keep going. So this is a very big deal. It's sort of, most people didn't notice. I think it's a real breakthrough in dealing with the catastrophic forgetting problem.
이러한 알고리즘은 catastrophic forgetting을 극복할 수 있는 중요한 브레이크트루라고 생각합니다.
There's another problem with machine learning, and that's explanation. Machine learning tends to be a black box. So yes, it can solve hard problems, but if you're a doctor and the thing tells you to provide a certain treatment recommendation to a patient, and the patient says, why? And you say, well, I don't know. I mean, the machine told me to do it. That's not acceptable.
딥러닝의 또 다른 문제는 블랙박스 문제입니다. 블랙박스는 왜 그런 결정이 내려졌는지 알 수가 없다는 뜻입니다. 만일에 의사가 환자를 진료한 뒤에 자기는 단지 AI가 시켜서 그랬다고 하면 이는 받아들이기 힘든 문제입니다.
So we're going to have good explanations, and there's now a program at DARPA, the Defense Advanced Research Projects Agency, on XAI. It's run by Dave Gunning, and it's all about opening up these black boxes so that we can provide high-quality explanations. And there may be a performance hit associated with that because you have to add additional machinery to do it.
현재의 머신러닝은 이것이 단지 고양이라고 설명을 하지만 XAI explanation은 이것은 고양인데 왜냐하면 이것은 form, physical, claw를 가지고 있기 때문이라고 설명을 할 수 있습니다.
Hardware is another key aspect of the AI revolution. You may recognize this device, which was in stealth mode until about spring of 2016. How many of you used Google search in the last 2 weeks? Raise your hands. You used this machine. It's a TPU, a tensor processing unit. It's optimized for running deep learning and other machine learning algorithms. In fact, it's an order of magnitude more efficiency, has more efficiency in computation than the GPUs and CPUs they were using before, and it plugs right into the Google data rack.
하드웨어도 매우 중요합니다. 이것은 구글에서 사용하는 TPU, Tensor Processing Unit인데 GPU보다 훨씬 성능이 뛰어납니다.
Data is considered gold or electricity in the AI world. And this company, Data has over $130 million of investment, and it can vacuum up data from all over the web.
데이터 마이너라는 회사는 인터넷에서 수많은 데이터를 모아서 실시간으로 정보를 발견해서 제공합니다. 분야는 뉴스, 퍼블릭 섹터, 파이낸스 등 다양할 수 있습니다.
500 million tweets per day, medical data, geographic data, weather data, financial data. It puts it through a set of machine learning algorithms, and then people who subscribe to particular kinds of data, say the latest in genomics data, can get a vector of information aimed right at them and their interests.
다양한 분야에서 현재 실시간 흐름을 벡터 방향을 제시합니다.
TensorFlow is another key algorithm in machine learning. This was developed by Alphabet. They invested tens of millions of dollars in it, and then they released it for free. So for those of you who are looking for a very powerful machine learning toolkit,
텐서플로우는 아주 강력한 머신러닝 툴킷입니다.
use this. It allows you to represent your problem like a data flow graph where the nodes of the graph are algorithms and the links between the nodes are multidimensional data arrays.
데이터 플로우 그래프를 사용하고 있는데 노드는 알고리즘이고 엣지는 멀티디멘셔널 어레이입니다.
And that allows you to distribute your computation across a broad fabric of hardware. So this merges or has a convergence effect with those TPUs that I mentioned to you before.
이러한 데이터 플로우 그래프는 계산이 여러 개의 TPU, 텐서 프로세싱 유닛에서 실행될 수 있도록 해줍니다. 어펜딕스입니다. 지금까지 시청하신 것으로 이번 차수의 수업이 인정됩니다. AI에 대한 발표자의 동영상을 계속 보도록 하겠습니다.
Talent is another key area of the AI revolution. Mark Zuckerberg hired this gentleman, Yann LeCun, who's an expert in convolutional neural networks. Yann is heading up the London, Menlo Park, and New York labs of Facebook, and they had a recent success in achieving human level and beyond accuracy in facial pattern recognition with their Deep Face 2 algorithm. This gentleman, Andrew Ng, was chief scientist at Baidu. They hired him from Coursera and Stanford about 3 years ago. And then just in March, Andrew announced that he's leaving Baidu. So it's very hard to hold on to your AI talent, and they really need to be courted in order to keep them at your organization. Here is a company called Viv. They have a bold vision for the future. AI and intelligence becomes a utility like Wi-Fi or Bluetooth, a utility that you can delegate work to, not just a tool. And here is a seminal demo from DeepMind that I've mentioned a couple times. This was from 2013. DeepMind created an Atari game player that started with zero knowledge of these Atari 2600 games emulated in software. They used a convolutional neural network, which is just a fancy word for a powerful pattern recognizer, and reinforcement learning, which reinforces an agent for a high score in a game. Take a look at this. This system is starting out with zero knowledge of the game. This is Demis Hassabis from DeepMind. You'll see the system miss that ball, and it's learning, but it's playing very poorly. After 120 minutes of training, it'll play at a mediocre human level, and you can see the mediocre human score there. But after 240 minutes of playing, the system will develop the strategy of burrowing up the left-hand side of the screen and playing from the backcourt where the game has no defenses. Take a look at the score. So that's a breakthrough, not just in game playing, but in AI. And people sometimes describe AI as a game-changing technology. But it's more than that. AI is altering the landscape of competition for all of us, fundamentally disrupting the landscape. Most of you have heard about the win of Alphabet's AlphaGo player over the world champion in Go, the Korean player Lee Sedol. This is really an amazing event that took place in March of 2016. Amazing because if you compare chess to Go, chess has an average number of moves per turn of 35. Go has an average number of moves per turn that are alternative moves, 200 to 250. So it's epically complex in its fan out. If you want to think ahead, you have to think with a fan out of 200 to 250. This gentleman had amazing grace under pressure. After losing 3 games in a row on move 78 of game 4, he came back with a 1 in 10,000 move and won that game. and now Go is more popular than ever. He credited AlphaGo with teaching him how to do that. And South Korea, after this game, promised to invest $3 billion for AI R&D after AlphaGo shock. You may